Hi, good evening, everyone.
Hi, good evening.
Hi, Vivek. How are you?
I'm good. How are you?
I'm good. I'm good, Vivek. So we will wait for 2 more minutes so that others they can join, and then we'll
Okay.
commence.
Or let's wait till 7:05. I think 5 minutes
Yeah.
either enough.
Okay. Otherwise, in the meantime, we can revise certain concepts which we have already revised
हाँ हाँ
last
ठीक है
last week.
ठीक है
Yeah. Okay. Is my screen visible?
या
Yes, sir.
Yeah. Okay. So we go to this. Okay. Okay, so today objective of this session is to carry out revision for week 5, 6, 7, and 8. So week 5, if we see week 5 basically deals with the logic-based coverage or logic-based testing. From where we got the predicates, and we know predicates they consist of the clauses, and so we have to cover either the predicate coverage or we have to have the clause coverage. Having predicate coverage does not mean that clause coverage has been obtained, and similarly, vice versa, clause coverage, if we achieve, it doesn't mean that we have achieved predicate coverage. Week 6 was the continuation of same concepts to the coding part, and in the week 7, symbolic testing was introduced, and then we came to psychological testing, which is DART. So we'll say that see that also, and then week 8, a new concept was introduced, which was functional testing. So let's come to week 5. So important concepts already have covered: predicates, predicate coverage, clause coverage, satisfiability, and tautology. ACC, that is the active clause coverage. Then the GACC, general active clause coverage, which is akin to ACC. Then we had CACC, then RACC, GICC, and RICC. So these topics we have done a session last week. However, I will do it again for the newcomers. So to cover all the clauses and all the combinations and all the predicates, the first is the combinatorial coverage. And if a predicate has got, for example, n number of clauses, then to have the clause coverage and the predicate coverage, we require at least 2 to power n test cases. So we see as the number of clauses they increase, this becomes computationally costly, and that's why it is not advised. For CACC, we need only n plus 1 test cases. That if there are n number of clauses, then by having plus 1 test cases, we can satisfy or we can achieve CACC. And CACC subsumes predicate coverage. It means if we have achieved CACC, then we have achieved predicate coverage. A GICC, which is general inactive clause coverage, it subsumes both predicate and the clause coverage. So if we see this diagram, can come handy in some of the objective questions. Combinatorial, it achieves everything. It has got 5 parts: GACC, CACC, RACC, GICC, and RICC. GACC achieves clause coverage. CACC, it achieves predicate coverage. GICC, it achieves both predicate coverage and clause coverage. And then we have got the restricted, their counterparts, that is RACC and RICC. Now, this evaluation process I got from some other external source I wanted to share with you, that how to obtain GACC, CACC, and RACC. Because I found personally it was quite confusing in some questions and in some other questions. So it's a process stepwise. First, we have to select the major clause. Number two, we have to determine the conditions for the minor clauses where the major clause determines the predicate. For GACC, select a pair of conditions where the value of major clause changes And the value of minor clauses or predicate may or may not change. That is one of the difference. And in CSCC, we have to select those pair of conditions where the value of major clause also changes and the value of predicate also changes. For RACC, along with the CSCC, we have to keep those conditions where the values of minor clauses they are held constant. So we will do some questions taking all these steps so that we go systematically.
Yeah, it's one this thing. One.
Yeah.
So I'm still confused between JSCC and CSCC. I get the clarity comes, but again I get confused.
Okay. Okay.
Uh,
So there is an example I will share with you.
Okay,
In
okay.
the course, that example has not been shared, but I got one example from online resource where GACC was different and CACC was different. Otherwise, in almost all the examples of the course material, the GACC and CACC they remain the same.
Same, right?
Yeah, and
Yes,
I might have included that example here also. We will see as we go ahead.
yes, sir.
Yeah. So, for example, this is a predicate. Predicate P is equal to A and B, or not A and not B and not C. So I have followed those steps only. So step one, select the major clause. For example, we select A. Now from here, to find GACC, find the minor clauses conditions when A determines B. And this is the procedure which we apply. So what we do, first we make A as true. We do this, and in the second we make A as false, and then we do the XOR for that. So when we solve this, we got B XOR not B not C. So from here, when we solve, I got B or C. Now, what can be done? For example, if some people they are finding solving this difficult, then what or from here how to come here if they are finding difficult, then what they can do, they can make the truth table for the predicate, and wherever this is becoming true, select only those rows for the B and C. So for example, in this case, select only true, 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 false, false, true. And for GACC, the predicate does not matter. So what we do, we take these B and C values, which we got true, 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 false, false, true. And once we keep the major clause as true, and second, then we keep the major clause false. We are not worried about what is the state of P. So here we got, for example, 1, 2, 3 is for the true and 4, 5, 6 for false. So we get combinations 1, 2, 3 into 4, 5, 6. So we will have 9 combinations for GACC. Now when we come to CACC, Vivek, pay attention here. So this is the example which I was saying. This is a perfect example to differentiate between GACC and CACC. So here we have got 9 combinations. We can see this part is clear.
Yes, this is clear. But
Yeah,
I have
very
some
good.
more questions. But you explain the whole thing, then I'll ask.
Yes, yes. So now to obtain the CACC, now what we do, we obtain the predicate value now for these conditions. Okay, we have taken the GACC conditions and now we calculate or find what is the predicate value. So see here, to find whether to say that it is a CACC, here 1, 2 and 6 predicate is true. So I get 1, 2, 6. 3, 4, 5, it is false. So this is 3, 4, 5. So again, I make 9 combinations here and I start checking whether my CACC criteria is fulfilled or not. CACC criteria, what does it mean? It means that the major clause is determining the predicate. So I start with 1, 3, for example, the first one. So 1, 3 says A is true, A is true, and here one's predicate is true and second predicate is false. It means for this, A is not determining P, so I discard 1, 3. I come to 1, 4. I see 1 is true, predicate is true, A is false, predicate is false. It means it is determining. So I keep 1, 4. Then I come to 1, 5. True, false, true, false. I retain this also. I come to 2, 3. True, 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 false. It means it is not determining. So I discard 2, 3. I come to 2, 4. True, false, true, false. Yes, it is determining. Same for 2, 5. And same for 3, 6. Now this case is interesting. 3 is true, false, false, true, true, false. And once I'm changing to false, it is becoming true. So in this case also, A is determining. So GACC, I had got 9 combinations, but for CACC, I have got 5. So this is the difference between the GACC and CACC. Now, Vivek, you can ask me the question.
Yeah, CACC is very clear, perfect.
Yeah.
But if you can just go up on the GACC.
Yes.
So just go up. Yeah. My first question is, this how quick, I mean, what logic do you use to determine this?
Okay.
This, I mean, this, no, I'll just tell you which one.
This one, B or C?
I don't know the, yeah.
Okay. So how do we do that? Like I say, there are 2 ways. If you don't want to come, that's why I covered. If you don't want to come here, for example, if you are facing difficulty here, what you can do, you can make the truth table for the predicate. So you will have 8 rows in the truth table. That's okay, Vivek?
Yeah, that's okay. But if you just explain it, because I have no, software background.
Okay.
My domain is finance.
Yeah. Okay.
So I'm just going. So B has to be true, and in XOR, this not B and C has to be false, right? For XOR to be true.
Okay.
So if I put not and I use De Morgan's this thing, then if you can explain it that way, I'll understand.
Yes. No problem. I will explain. So till here, you have understood how we have come till here. True. Okay.
Yes.
Okay. So this was B XOR not B and C. It is B XOR not B or C. Okay. Yeah. Oh, sorry. This is AND. Not or. The XOR difference is only this, that if it is true false, then only it will become true, and false true, it will become true. If it is false, it is false, and if it is true, it is false. This is XOR, exclusive OR. Now, what you will do to find the conditions for this? What I do, I select B, I take C, I take not B, I find not B and C, and here I will do not B and C with D. So let's call it is A. So A XOR B. So this can be true, not B becomes false, true, false, it becomes false, false, true, it becomes true, false, it becomes false, not B and C, false, not B and C, false, true, false. Now for XOR, if we see these conditions, I have to do with B now. So true, false, true, false, true, false, true, false, it is false. So from here,
clear.
Yeah. So this is clear?
Yeah, clear.
Okay. Now if I see, now forget okay, these conditions. Now I can make B, C, and this is my result. Okay, for example, let's call it a predicate. For example, P1. So it is giving me T, 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 F, T, F, T, T, and F, F, F. Now, if you see, this is nothing. This is B or C. This is the B or C conditions.
Yes.
So,
Yes, sir.
yeah. So this how I got a B or C. However, during the exam, this for concept building, it is okay. But during the quiz, due to the shortage of time, if you find difficult to come arrive at this place, what you do, there is a shortcut. So what you do, you make the truth table for the predicate, the entire predicate. You do A, B, C, and P. Okay. And here now you will have 8 rows.
Right.
And this will be false, true, 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 false, 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 true, false, 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 true, and false, false, false. So what you do from here, you select these rows where this was true, it was becoming true. So here it was becoming true. So T, 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 F, F, T. So you select okay, these rows, T, 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 F, F, T.
Right.
T, okay, TT, TF, FTs. So these are your GACC rows. Okay. So without going through this process, if you find difficult, you can just 1, 2, 3. These are for true, 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 and these are for false, which we had done, which was TT. So this TT. This is for false, TT, TF, FT. So I get combinations 1, 2, 3 for true, and 4, 7, 8 for false. So test cases I will get 9, 1, 4, 1, 7, 1, 8, and so on for 2 and 3. Now is it clear, Vivek?
Absolutely. Thank you so much.
Yeah.
Thank you so much.
Yeah. Okay. You're most welcome. And this was a very, very good example where we saw that there is a difference between CACC and GACC. So for GACC, I don't have to worry what is predicate. Predicate can be anything. Only my major clause has to change. So from here, I get the test cases. So when we proceeded to CACC, now I become concerned with the predicate. So here I got the predicate, and here also I got these combinations, and these combinations one by one I checked to check whether they are fulfilling the criteria for CACC or not. So from here I found only test cases how many? 5 only. Now for RACC there is again one more restriction, that the minor clause has to be same. So now here 1, 4, 1, 5, 2, 4, 2, 5, and 3, 6. Now I check this. So I come to 1, 4, 1 and 4. Yes, minor clause is same. So my 1, 4 is a RACC. I come to 2, 4. TF, TT. No, it doesn't fulfill. I come to 2, 5. TF, 5 TF. Yes, now it is 2, 5. And 3, 6. 3, 6 is false true, false true. Yes, it is a RACC. So in this example, we have seen we got GACC 9 combinations, CACC we got 5 combinations, and RACC we got only 3 combinations. So with this example, I hope finding GACC, CACC, and RACC is clear. If anybody has any doubt, you can ask me. I can cover again. Abir, okay, is it clear? We had done the same thing.
Yes, sir. Yes, sir. It was this was clear the last time you explained.
Yeah.
So I'm just revising in my mind.
Okay. Thank you. Thank you. So we go ahead okay, with this. So these are certain GAs I have taken. So in the GA, this predicate was there, A and not B or C. So just now what we did, we had done and C. Here they have given or C. So just follow the same procedure. If you follow the procedure, so first step one, they have asked for major clause A. We find PA. Again, we followed the same procedure and we got not B or C. So not B or C, and you don't have to even remember this. If you are not getting this, for example, just take these values. TT, FT, FF. You just write here. TT, FT, FF, make a true, make a false, and you will get GACC. So again here you will get 9 conditions. For
Sir,
CACC,
can you just repeat this again?
yeah. So what I said, Abir, for example, if you are not getting this, that not B or C, you are not able to get this.
Yes.
So from here, you just select the rows where this clause is becoming true. This is
True.
PA.
Correct.
So
Yes.
this true, this true, this true. So
Okay.
what? TT, FT, FF. So you write TT, FT, FF,
Understood.
make A once true, make A false.
Understood.
So you get 9 conditions. Now for CSCC, what do? I find predicate value. So see here in this case, your GACC and CSCC, they remain same. There is no difference.
Yes.
Okay. Now when we come to RACC, we have to keep the minor clause constant. So
Yes.
1 and 4, 2 and 5, and 3 and 6, they
And
are the
6.
RACC.
Yes.
Okay. So with this, I hope this is clear. Now we come
Yes.
to GICC and RICC. How to find that? Now for that, there are no steps. For what we have to do, inactive clause coverage means that this clause which I have selected, it is not determining the predicate. For example, if I select major clause to be A and apply inactive clause, it means if A is true, predicate is true. If I make A false, my predicate remains true. It means A is not determining P. For P is equal to false, again, A is equal to true, P is equal to false, A is equal to false, P remains false. So these are the 4 conditions I have to check to find those combinations for the GICC of for A. And once I have found the GICC, then I find the RICCs by finding those combinations where the minor clauses are not changing. So for this, again, we take an example, A and not B or C. It is the same example which we did earlier. So for this, what we have to do, we have to make the truth table. A, B, C, and now I check A is equal to true, P is equal to true. How many rows? 1, 3, and 5 is this. A is equal to false, P is equal to true. There is no row like this. So for P is equal to true, there is no GICC or RICC. For P is equal to false, A is equal to true, P is equal to false, it is in the second row. A is equal to false, P is equal to false, there are 4 rows. So here I get 4 combinations, 2, 4, 2, 6, 2, 7, 2, 8. These are the test cases. So these I have got GICC for A, and all of them are for P is equal to false. Nil for
But for A equals to true, there is no GACC because there is no A equals to true and P equals to false.
yes,
Okay, I got it.
yes. This condition which is there is equal to false, P is equal to true.
Yes.
There is nothing. Now here again I apply the same fundamental to find the RICC, and I one by one I check 2, 4, 2 and 4. These are different. 2, 6, true, false, false, true, different. 27 true false, true false. Yes, 27 is my RICC. 28 true false, false false. No. So this is my RICC. So this is how we find GICC. First we find GICC, and from GICC we arrive at RICC. In this, any doubt till now in RICC or GICC? We will solve some questions further.
Yes, it's clear, sir.
Clear.
Okay.
And there is no CICC for
Yeah.
there is no CICC, right?
Yes. There is no CICC. Okay. So here I have taken a question from the PYP, and they have given us a truth table. And from the truth table, only for my understanding, I had made out that what is the predicate. But from the truth table itself, we can draw what are the things which they are asking. So with reference to the truth table, row numbers, identify the GACC pairs for clause A from the following options. They are given certain options. However, for my understanding, I calculated. Can somebody try this again? How to find the GACC for A from here? Abir, can you try this?
Yes, sir. Trying. Yes, sir. Trying.
Yeah. In the meantime, I will just explain how I did it here, because I found that method slightly to be much what I have been following. So what I did, I took this table and I tried to make out that what is P. So A, B, P, true, 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 false, 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 true, true, false, false, true. So my reasoning was that here this P which is there, it is depending on B, not on B. Sorry, A. If we say not A or and B, do we get the same reason? No. It could be
No, sir. We don't. It will be or.
Yeah. So not A or B. Not A or B. Not A or B false. Not A or B true. Not A true. So this I have got this, and now once I got this, then I calculated the GS. So if we follow our steps, what we have learned. So what do? We find the PA. PA in this case will become not A versus B. So we make A as true. So this will become false versus B. XOR false, it become true versus B. If it is false, then it will depend on B. If it is true, it will not depend on B. It is T. And we make these conditions B XOR T. B can be true, B can be false. T and T is false. T and F is true. So I have to select only this part for the GACC. FT, FT. So I see here, where are FT and FT? So B, I select F. So A once it will become true, and A once it will become false. B remains the same. So my GACC rows will be TF and FF.
So 3 and 4.
TF and FF. So 2 and 4 are my GACC.
TF
Vivek?
and FF. Yes.
Vivek, could you understand this?
Yes.
Yeah.
I'll go through your recording and work out with pen and paper. Then I'll
Yeah.
whatever you've done.
Yes.
But it's
And-
clear.
Yeah.
Conceptually, it's clear. Thank you.
Yeah. And in this case, I asked, is it CACC also? Yes, it is CACC, because B is remaining same. Only A is changing. So my it is CACC also. Predicate is different here. Predicate
Yes, and it will be RSCC as well.
and it will be RACC also.
RACC also, right?
Yeah. And Now consider the predicate again. I think the same predicate A and minus B and C. So this I have followed again the same steps. You do, you will find it. I'm just following the same steps again, no change again. So these are the things okay, which I have done. So these are certain uh, previous year question papers I have solved for RICC and RICC. Now remember this, that for RICC you have to find first GICC, and this you can find only using the truth table.
Okay.
Okay, for that okay, there is no shock. So this so with this I have covered the main important points of the week 5. So shall we proceed to week 6 again? Or can we take
Yes.
1 minute or 2 minutes break? I'll have a glass of water.
Please, yes.
Yeah.
Yes.
Yeah, I'll just come. I'll have a glass of water. Hi, I'm back, I guess. So we'll start okay, commence.
Yes.
Okay, so now we come to week 6. So in the week 6, the important concepts which have been covered is basically first is the CNF. What is CNF? CNF is basically when it is and what is her disjoint normal form? DNF is when it is OR. And they have given us a nice formula to find the ACC for CNF and for DNF. So for the AND part, what you will do, for example, I have taken an example of A and B and C. So make all the values true first.
Okay.
Now true and change for A. You have done again, for example, F. Okay.
Okay.
Now keep all values true, only take diagonally F.
Got it.
Okay. And this here, ACC, which you are getting, earlier what we were doing, we were finding for PA. This is the
Yes.
combination of all PA, PB, PC. So these are the 4 test cases for entire ACC.
Okay.
Okay. For DNF, we do opposite. What do? We fill all the values false. False,
Okay.
false, 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 false. And now diagonally change it to true.
Got it.
So this becomes true, this becomes true, this becomes true. So this is the ACC for A or B or C. So this will come very, very handy.
Okay. All 4 of these are ACC for OR.
Yes, yes. For
Okay.
all.
Got it.
For
Got
all.
it.
For all.
So I had one question.
Hi,
So
yeah.
most of the predicates are either in and or.
Yes.
So I can directly use this for my ACC in the previous week 5 also. Can I not?
Yes, yes, you can do that. Unless they are of a different format, like something is like you are finding different, difficulty like this. So this is neither in the, here it is in CNF, here it is in DNF.
Okay.
So can't we find the DNF in the bracket?
Yeah, yeah,
And
we
Yeah.
can do that. We can do that.
Yeah.
yeah,
So
so
Find the DNF in the bracket and then yeah.
yeah, we can try that again. So here in these questions, week 6 questions, okay, this criteria will come handy. I think in the week 5 they were trying to make our, build our concepts, and to finally we have to apply this concept on a code.
Right.
You know? So week 6 is finally about, okay, applying these concepts on the code. So here I have checked also that whether it was conforming to our earlier understanding or not, and I found it is entirely correct. Okay, so this document, okay, I will share with all of you. Now, some concepts from week 6, that in the finite state machines, it is the predicates which are coming from transitions. Okay, and when we see the code, from where we get the predicates, we get from if, okay, for, while, okay, else we don't get, only from if, for, while, do, while, all this, okay, we get the predicates. Now coming to this, what you asked, okay, how to apply this on a code. Now this is a code. You can see this code, and we have to find the RACC for this code. So how to do this? So I will go step by step again to make the things understanding clear, and we'll find the test cases for RACC. So see, in this code, you can see there are two predicates. One is here, second is here. Okay. And what I will advise all of you, what I follow, what generally I do, I make some kind of graph to understand this code, what is happening. So it is a two prad, we get x, y. There is a boolean z. Here is a condition, x is less than y. If it is false, then z is equal to false. If it is true, again I'm checking one more condition, z and x plus y equal to 10. If it is true, return a. If it is false, return b. So I have to have some test conditions. So for the test conditions, what you can do, you can find the paths. I have to cover this path. I have to cover this path. And I have to cover this path. Is this clear, Abir?
yes, sir.
So this point which is there, here I can write this as z. What is z? Z is nothing but it is x less than y. I can write this predicate, and x plus y is equal to 10. Now this is a part, Vivek, where our this understanding will become clear, that CNF. So this is A and B.
Yes.
Now for this test case, I know how to build the test case. I make everything true, 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 and I diagonally I make it false.
False. Right.
Okay.
So I get here 3 test cases for this. TT, FT, and TF. Now what is the meaning of this TT? TT is that x is less than y and x plus y is equal to 10. Second is x is not less than y, x plus y is equal to 10. TF, x is less than y and x plus y is not equal to 10. So these are the 3 test cases I have found.
Got
And And your subsequent questions in that, okay, they will give you that which are the test cases which are sufficing. So first, okay, thing we have to check that whether the number is matching or not. That there have to be 3 test cases. If they are less, we check that. Then we check, for example, they have given, for example, they give 4, 6, 6, 4, 5, 5, and 4, 6, 6, 4, 4, 5. So which will match the test case? So we check one by one. So 4, 6, x is less than y, x plus y is equal to 10. So my first test case is achieved. X is not less than y, this, x plus y is equal to this, achieved. 5, 5, x plus x is less than y, no. So this is condition third is not achieved. So this test case is not achieving. Here first, second, here you see, here it is achieving x is less than y, yes, achieving. X plus y is not equal to 10, yes, achieving. So this is how we find and select the option which is achieving my test case. Is this clear?
Yes, sir. Thank you. Now it's very clear. I
Yes,
was
sir,
doing
it is
it
clear.
by intuition actually. I was just
Thank you, thank you. This is the aim of learning from each other, because I find it is much better, because
yeah.
all these lectures, okay, especially software testing, they have been very monotonic, no practical example, and suddenly they ask questions, okay.
This was very helpful. Thank you so much. I'm glad I attended it.
So now let's see. We find the RICC for the same. Hello. So we have seen RICC. We finally what we did, we made A and B. This is the one which we have got. So we make a truth table for this. So we get the truth table. TTT this. Now we know that for RICC, what are the procedure? We find these conditions. First we find GICC. So GICC A we find A is equal to true, P is equal to true. Yes, first row. A is equal to false, P is equal to true. Any here? No. So this no GICC. A is equal to true, P is equal to false. Yes, 2. False, 3 and 4. So I get 2, 3, 2, 4, GICC alpha. Similarly, for GICC Bravo, I find 3, 2 and 3, 4. So, and all of these are for P is equal to true. For P is equal to false, there is no GICC. Okay. And we can say that, and now from here we can find the RICC also. So 2, 3 and 2, 4, 2, 3, 2, 4, we got 2, 3. 2, 3 is a RICC for alpha? No, because my minor clause is changing.
Yeah.
This is RICC. So 2, 3, 2, 4 has become for A. And for B, 3, 4, because A is not changing. So I got RICC for alpha, RICC for beta.
Got it.
So this is also from the PYP. So now we go to another question. And this is a question. So I will cover the steps again. So again, what do? We make a graph first, okay? It is taking A, B, R is equal to false. Condition is A is not equal to B. If it is false, we don't know what is happening. If it is true, then it makes R is equal to true. And now there is another condition. R means A is not equal to B, or A is the B. Then if it is true, we return B. Or if it is false, we return A. So this is the predicate which we have got. The predicate is A is not equal to B. or A is less than B. So this we know that this is A or B. We know how to find the ACC criteria for this. So in ACC criteria, we make everything false, and then we make the diagonal. This in this it will not come, so this becomes true, and this becomes true. So ACC criteria is false, false, true, false, false, true. And now we check these conditions. This is A, this is B. So I will get 3 test cases. And then I check the test cases. If they are fulfilling this requirement, they are good. Otherwise, they are not. They are not satisfying this test case. Is this clear?
Yes, it is clear, sir.
Okay. So I have done the same thing. I have same steps. So ACC I have found, and from that I have found the RACC. RACC I got this. RACC B I got, and then I got RACC combined. And then for the RACC, I made the truth table for A and B, and I found RACC alpha, RACC bravo, and then I got the RACC. Okay, so this was the week 6. Okay, all the main concepts and the main questions from week 6. Any doubt or any clarification, any addition in this?
This recording
No,
you are
sir,
going to
it's clear.
upload, right?
Yes, Vivek. I will upload this recording. I'm recording this. Okay, so now we go to week 7. There is no further this, and I will share this PDF document also. In this, all these questions have been solved. So in the week 7, we have come to symbolic testing, that we don't give the values, we take those values as symbols, and we do the symbolic testing, that how those values are changing. And then we got something called DART, which is a form of concurrent execution, that on a fly, what it does, it gives the values, finds that, then it generates the predicates also to check the paths. So we will see all this with the examples. So this is the first example. I will take this to the next one here. And on all these examples for week 6 and week 7, I have found. So here the question they have asked, that what will be the conditions when you reach assert false. So for that, again, you can make a graph x, y. X is greater than y. If it is false, we don't know what is happening. If it is true, then it does some assignments. X is equal to x plus y, y is equal to x minus y, x is equal to x minus y, and again it checks x minus y is greater than 0. If it is true, then it asserts false. If it is false, we don't know what is happening. So see the path, okay, they have asked in the question that how to reach this path, what will be the condition here. So to reach this path, first this has to be true, x has to be greater than y, and x minus y is greater than 0. And what I will cover, okay, DART also here. What DART does, it comes here, first okay, DART takes some random values. For example, it will take, okay, for example, 2 and 3. And in this here, we can see that there are 3 paths. One path is this, one path is this, and the third path is this. And testing involves that we should test, okay, all the paths. So randomly he has selected, for example, 2, 3. So here 2, 3 will become false. So this path he covers. But here he knows that it is a predicate. So it generates a value for x greater than y, so that it can see this path also. So here again he will make, for example, 3, 2. He comes here, does these calculations, Now he sees here x minus y is equal to 0, for example. So here in this case, it will become x is equal to x plus y, 5, y is equal to x minus y, 5 minus 2, 3, x is equal to x minus y, 5 minus 3, 2. So it has done reversal. Now it sees x minus y greater than 0, 3 is greater than 0, it will come here, but it is a predicate. Dart, it will check this path and now generate some value to cover this path also. So here again, it will generate 2, 3. This is how Dart does. Now to reach here, this is the condition which we have to meet. And on all the questions in week 7, they are asking only these conditions, that what are the conditions which will be formed or which should be satisfied.
Can you repeat this last one again? How the Dart will again change this to 2, 3?
Yeah. So Dart, what it does, I'll cover the procedure of the Dart.
So don't erase it.
Yeah, no problem. So Dart is doing both concrete, taking concrete values and symbolic values both on the fly. And basically,
Okay, but here you have just given values, no? So we are
yes,
taking
yes.
concrete here.
So what it does, okay, for example, here it is starting. This is x, y, x less than y. So here it will start with some random value, 2, 3, for example.
Right.
Now 2 is not less than 3, it is false, so it achieves this path. But he knows that this is a predicate. To achieve true, what it will do, it will assign new value now. Here it will assign 3, 2 to cover this path.
So this, my question is here, where
Yeah.
when it goes to this 2, 3, it is the concrete values it's giving.
Yes.
The next one, it does it through the solver, SAT solver, gives
Yes.
symbolic.
Yes. You're right.
Okay.
Yeah. So now it will comes here, does all these assignments, and we saw what happened. X is equal to x plus y. Y is equal to x minus y. X is equal to x minus y, and finally they got reversed. Y became 3 and it became 2. Now it comes here, x minus y is greater than 0. So in this condition, it is true. So he comes to this path. But here he knows that there is a predicate. So again, what he will do to cover the other part, he will make x minus y less than greater or equal to 0.
Okay.
Okay. So on this, let's see what are the kind of questions they are asking. So I'll go to the previous question only here. In this question, they have asked find the number of paths. So we have seen there are 3 paths. To reach assert, what will be the conditions? So like I mentioned earlier, I generally take the help of the graph. And when you make the graph, your things become very, very clear to all of us. So there are 3 paths. One path is x less than y. Second path is x is greater than y. And x minus y is greater than 0. Third path is x greater than y and x minus y is less than equal to 0. Sorry, my mistake here. This would be the third path. Okay. Now with this, can I request both of you try this, generating the path and conditions for this.
Okay.
This is an example.
So we'll have x and y as my values.
Yeah.
And then we'll go to first condition, yeah, decision, x less than y. So that can be false, then we get nothing. We don't know what we get. And then true, we'll come to square of, that is x into x.
X is less than double it y.
That's it, yeah, 2 of y, right.
So we see there are 3 paths here, 1, 2, and 3. Okay.
Right.
and they will ask a question that what will be the condition to reach about. So to reach about, it will be x is less than y and x square is less than 2y. And what is the predicate which he will form here? He will predicate form to achieve the another path, x square is greater than or equal
Greater
to.
than equal to, right?
Okay, and here he will make x less than or equal to. So this is how he does. Yeah. Okay, so this is another question you can. So this is very very easy if you have understood this concept. In only this, there is a catch which I want to cover, is the infinite loop. So infinite loops here they have given an example, or I have taken from the PYP. This is one example. I will zoom it slightly. And can you see that's like a, Abir, is it visible?
Yes, sir, it is visible.
Okay. So this is a function in positive sum. Input is S. Assignment I is equal to S. Sum is equal to 0. While true, I is equal to I plus 1. R is equal to input. If R is less than 0, this is R less than 0. If it is true, break. If it is false, it goes to, it updates sum here. Sum is equal to sum plus R, and then it goes here. So see, it will keep on going infinitely till the time your R is greater than or equal to 0.
Yes,
Only when it becomes R is less than 0, it will break. So for these
yes,
kind of things, what do we make? How we denote them? We denote them that I belonging to, in this case, you see, it is I is equal to S, I is equal to I plus 1. So from where it is starting? It is starting from S plus 1.
yes,
Right.
It will go from S plus 1, it will start. It will go to some value S plus 1 plus N till the time your R is greater than equal to 0.
yes.
And the break condition will come, your R
It's
S
less than 0.
plus 1
Let's
plus N plus 1. Is this clear?
Yes, yes, yes,
yes,
yes, yes.
yes.
And this is 0.
Okay.
So in all the questions of this type, be careful to see from where it is starting.
Okay.
Okay, that is the only
This
criteria.
the second one will come if we give. Okay, we can only give one false. With one false condition, it will come out.
Yeah.
So that's with in the and condition, right?
Yes, yes.
Okay.
Okay.
Yeah.
So here I have written also that carefully see from where the values are increasing and what are the break conditions. So now this is another question. This I will give it to you. You solve this. Try to form. So this is the again loop question.
Okay.
So okay, let me try. So this is S and D are the input.
Yes,
I is equal to S minus 1. Okay.
yes,
Do. What do we do? We do I is equal to I plus 1. R is equal to input. While R percent D is not equal to 0. So we put check the condition. R percent D is not equal to 0. If it is not equal to 0, it will go to here. If it is false, it returns I. So again, this is an infinite loop. So
Yes.
for this, what we will make I belonging to, now see from where the I is starting. I was S minus 1. Here it did S minus 1 plus 1. So it is
So
starting from S.
S. Yes.
So it will go to S and it will go up to N, where R percent D is not equal to 0. And I belonging to, now this is S plus N, sorry. And here it will go to S plus N plus 1,
Plus 1. Right.
where R percent D becomes 0. So this is the condition.
Right.
So just we have to check from where it is starting, what is the loop condition, what is the break condition, and you'll get the answer.
Got.
Okay, so this was week 7, that tricky questions now. So this, you will be able to do this question. This was the question. This again is a simple question. So you come here, follow the loop. They will ask that what are the conditions to reach line 2. At line 1, what are the predicates he is forming? So see, in this question, this from here we start, we get this, we get R is equal to 0. So first 2x greater than 0, false. So we get first path here. If T2 minus T1 is greater than 0, second condition. If it is false, second path. Else is coming here. So here, to come here, they will ask that what are the conditions to reach again line 2. So it will be 2x greater than 0 and z square minus y square is greater than 0. They will also ask, okay, they have also asked that line 1 pay, what are the predicates he has formed. So at line 1, he will form the predicates 2x 0 and he has achieved this condition. Now to achieve this condition, he will make z square minus y square less than equal to 0.
In this, there are 4 parts, right?
One part this, second part this, and third part this.
But actually, there are 4 parts.
Where is the fourth part?
If this is okay. Sorry.
See, this is
Sorry. Yeah.
yeah.
Yes,
One predicate, two
yeah.
predicate. Okay,
Yes.
there is no other.
Yes.
Yeah. So you practice again, you go through these questions, things
Yes.
will start
Yeah.
looking very, very simple. Like once.
Right.
Yeah. Okay. Now we come to week 8 concepts again. So week 8, initially they have taught us software development life cycle, which we have learned during software engineering.
Yes.
And then they covered the requirements. So requirements, they can be classified in 2 ways. One is product requirement, another is process requirement. In product requirement, we specify basically how the product should be, and in the process, how that product should be, what are the process involved to get that product. And then the requirements which we know from software engineering, they can be user requirement, business requirement, functional requirement, non-functional requirement, or the regulatory requirements. So I feel that okay, we can do this. And now from here, they introduce us to functional testing. That what are the how to achieve functional testing. So in the functional testing's main important part is that first we have to identify the domain of each input and each output variable. What is the domain? Select the values in the domain. So if there is a method, for example, in some software A, and it has got 3 characteristics, P, Q, R. So first of all, I should know what is the domain. These are the 3 characteristics. I will be knowing the domain of this. It might be int, it might be some date, it might be again some string. And in the question, so that's why domain knowledge is important. I will be knowing that what is the domain, that from here to where, from where to where, from where to where. Then what do we do? We make the partitions of these domains. We make the partitions of input variables. And then we give values one by one in the combinations to check whether my output is matching with this or not. So this is the functional testing. I will cover it here in detail. So what are the types of functional testing? One is the equivalence class partitioning, that we make the partitions. I'll give an example. Boundary value analysis. Now once we have made the partitions, now there are three guidelines to carry out a boundary value analysis. If the partition is in range, for example, we say that it is from 1 to 100, one partition. So it is very, very important that we check min minus epsilon, maybe something 0.5, at min plus epsilon, for example, 1.5, then at max minus epsilon, at max, and at max plus epsilon. Because most of the software developers, they make mistakes at the boundaries. So these are the conditions to check when the partition is we have made in range. Min minus epsilon, min plus epsilon. So it is like 1 to 100. I will check here, I will check here, I will check here. Then I come to max, max minus epsilon, at max, and then at max plus epsilon. So this is for the range. Similarly, if it has been given in values, I do the same thing. However, if it is given in a set 1 and 100, then I don't do all this, epsilon and all that. I check only at the min value and the max value. Is this clear, Abir?
Clear, clear.
Yeah.
Yes, sir.
Now we come to the decision tables. Now, if you, for example, we have got three characteristics, then there might be some conditions. They have given an example of bank loan, that your age is more than this, your gender is this, your income is this, then I will give the loan. So these are the how we join those conditions to make the decision tables. Random testing, we randomly select inputs. Pairwise testing is an important, I will cover it, and cause effect diagram. So let's come to the input space partitioning. How do we do that? So like I said, the set that is split into a partition while doing testing is the input domain. We always do the partitioning on the input domain. For example, they have given an example that if your income, in some questions in the PYPs, they have given the domain also, that, for example, age, valid age is from 18 to 80. And there are certain conditions. If age is more than 18, then you will get 10,000, for example. Age is 18 to 20, you will get 20,000. Your is 21, it's 21 to 30, 30,000. 31 and above, you get 50,000. So here, how do we make partitions? To make the partitions, it is very easy. Just make a line we used to do in the school. Make the minimum part. This is 80. 80. So one partition will be less than 18. One. Second partition 19 to 20. 21 to 30. And above 31 is, for example, they have given 31 to 80. This, and above 81 this. Fourth partition here, fifth partition here. So this is how we make the partitions from the question. Just make a line, denote those, and you will get the number of partitions easily. I'll just cover this here with examples of PYPs. Input domain can be several different sets, one for each input. When we have a different characteristics, we may or may not consider all the inputs while doing partitioning. Each partition represents one characteristics of the input domain. So this, each partition is based on some characteristics. Now this, what do we mean by characteristics? I will cover, for example, there is a method A. I can have different parameters to this. So these are the characteristics of this. And we make partition on each characteristic. Okay, for example, I just covered age. There might be on income, there might be on gender. Now, on the basis of this, depending on the domain, I make the partitions for each characteristics. Now, there are two
So I,
properties.
I have one doubt here.
Yeah.
So so my partition will be age, income, and gender, and within age I'll have further
No, no, no.
block.
So I'll cover it here only. So I have got here, for example, this is my method, age, income, and gender. Okay. So these are my three characteristics. For age, I will make some partitions depending on the domain. Okay. So I will have one partition less than 18, 19 to 20, 30 for example, 31 to 50, above 50. This is partition for age. For income, and let's call them a partition A, B, C, D. For income, I have got less than 10,000, 10,000, 1 to 20,000. For example, only there are two partitions. I call these partitions as 1 and 2. Gender also, I just consider male and female. So here also I have got two partitions, let them P and Q. So these are the partitions. Now, when I do the testing, when we will go further, it will become clear to you. So these are the partitions for each characteristic. Okay.
Clear, sir. Yeah.
Yeah. So these are the characteristics, and completeness and disjointness means what? That when I make the partition, and for example, here age for me, example, age domain has been given 18 to 80. Okay. Or for example, 0 to 80. So my partitions, they should cover the entire domain. Are they covering? Yes. Less than 18, it is covering. 19 to 30, it is covering. 31 to 50, it is covering. And above 50, it is covering. So my entire domain should be covered. Second part is disjoint. Disjoint means that they should be not joined. There should not be any overlap. So this is the golden principle to make the partitions. These are the two properties. So there can be some questions, okay, on this. In one of the PVIP, there is a question. Now the various coverage criteria that we'll be considering, these are the coverage criteria. I will cover them one by one. All combinations coverage, each choice coverage, pairwise coverage, t-wise coverage, base choice coverage, and multiple base choice coverage. So what is the meaning of all coverage? AOCC. For example, just now I said we had three partitions for age, for example. For income, I have got two partitions, 1 and 2. For gender, I have got X and Y. So these are the partitions this we can get. This is just an example. AOCC means that I check all the combinations, means A1, A2,
It'll be 12, right?
AX, yes. So it is for AOCC, it is the product of BI, where is the BI is the number of partitions. So this is 3 into 2 into 2 is equal to 12. Is this clear, Abir?
Yes, sir, it is clear.
Okay. Now this is computationally costly because here we are just taking 3. There are, as partitions increase, this will become computationally costly, and it is not feasible at all the times. The second part is ECC, that we cover each partition at least once. At least once. So how can we cover this? We can see this example. We cover A1X. So A1X I have covered, B2Y, and C I can select anything and I will be able to cover. For this, the formula is To cover the ECC, it is the max of BI. So here max is what? 3, 2, 2, 3. Three cases. Is this okay?
Right, clear.
Yeah. Now the third is pair-wise coverage. Now pair-wise coverage, what do we do? You make the pairs. So we will get A, B, C, 1, 2, X, Y. Now how many pairs can be there? Pairs can come from, so I will have A1, A2, AX, AY, B1, B2, BX, BY, and C1, C2, CX, CY, and 1X, 1Y, 2X, 2Y. Any other pair? I think
No.
no. Okay. So now to achieve this pairwise coverage, what they have given a formula, it will have at least max of BI square. So back BI is 3, max BI is 3, it will have at least 9 cases. And we can see how this figure has come. A1 is there, so I can select A1X. What I have done, achieved, I have achieved A1, I have achieved AX, and I have achieved 1X. Now I can go to A2Y, or I select, for example, I will more logical way, B2Y. I achieved B2, 2Y, and BY. I have achieved. Now I come to, so Y2Y 1X has gone. I select A2X, for example. So I achieve A2, I have achieved 2X, and I achieve AX already I had achieved, so I'm doing an overkill, but no problem. So I have achieved this. Now to achieve AY,
C. Take C.
yeah, you're right. You're right. So I should have done here C2 and I C2X, yeah. So here I will achieve C2, 2X and CX. CX I have achieved. Now what should I do? So this has been done. Now I start with, for example, AY. AY. 1 and 2, I have not achieved A2. So here will come A2. So I will achieve AY. I will achieve 2Y, which has already been achieved. AY has been achieved. 2Y. AY. A2 has been achieved. So no problem. I am achieving. Now I come to B1Y. So B1,
B1X.
1Y. Okay. And
B1X.
B1X, okay. B1X also. So then it will not make any
EX will also get cancelled.
Yeah. So BX will come. 1X is there. BX is there. B1 is there. And
Or C1Y only. That covers everything.
C1Y. Very good. C1. C1Y. CY. I think
We have 6. Okay, 9
1,
we need.
2, 3, 4, 5. No. We have made some mistake somewhere. Some mistake here. I will just cover here how I have done. See this ABC 12XY. So I did A1X B2Y, A2X B1Y, Or shall we try again, Akya? Just to have this, remove this confusion.
Let's, yeah. The combinations you can just copy because that's clear.
Yeah. Okay. Yeah.
The pairs. Yeah.
Yes. Yes. Okay. So use red. We take a1x for example. a1x, a1, 1x, ax. This is gone. Now I come to b2 for example. This I've done. I select b2y. So I will have b2, 2y and by. This is gone. Now I come, so I have achieved, now I come to cx and I see which is not achieved. So c1y, c1y, I achieved c1, cy, 1y. Now my 2x is remaining. So I can either achieve with a2, so I do a2x, a2x, 2x is gone, a2 is gone, ax is already achieved. Now I have to achieve, for example, bx, b1,
B1X. Yeah.
b1x, b1x. So here I will have b1 I will achieve and nothing else. Everything has been achieved. Okay. Now see, I have to achieve now bx. Bx has been achieved. Now I have to achieve c2 and cx. So c2x has been. If I do this, I can achieve in 6. 1, 2, 3, 4, 5, 6. In fact, on the WhatsApp, I think I had shared the same. That we are
Yes,
achieving
that's
in
what
6.
the question I'd asked, that it can be
Yeah, yeah,
done in less, and you
yeah.
said yes.
Yeah. So, but I think in this some catch is there. Some catch is there. We will ask on the discourse, you know, this question.
Yes, sir.
You know, this we will ask on the discourse. Otherwise, PWC is clear. And what they do in the TWC, here we were having only one value.
Here, how have you done? If you can just go up here. Okay. No, no. The
Yeah.
where you have solved at 9 cases.
Yes, yes.
Yeah.
So here you
Okay.
see A1x,
B2Y,
B2y,
A2.
A2x, B1y.
Okay.
Oh, actually, I have not changed like this. That here I can take only these values.
Yes.
Okay, that's all I got. I will think again. In case I get the answer, I'll post it
Yes.
on the WhatsApp. I'll post it. So here we were taking only one value. In the TWC, what they have said that you can increase the value. Like for the pair wise, we were taking only one pair, like A and 1. In the T, they are saying that you can increase the value. For example, we have increased to the 2, A1, A1, 2, AX, AXY. And for this, they have given the formula that max of BA and the value. But it is very, very costly and generally it is not followed. The next one is
So
the
this,
base. Yeah.
if T is 1, then it'll become ECC, right?
Yes, yes, yes.
And if
It
it
will be
is 2, it'll become this.
PWC.
And if it is all N, then it'll become that ACOC.
Yes, yes. All combinatory.
Okay.
Yeah. Now then they came to base choice coverage. That if you do the base choice coverage, so what happens in the base choice coverage? You choose one best base test. For example, I have selected A1x, and now keeping two values constant, you change the third value. So for example, here A1 is constant, x and y. Now AX is constant, 2 I got. 1x I got constant, so I got B, then 1x I got C. So total number of cases became 1, 2, 3, and 5. And for this, the formula is 1 plus
So
I
how did you get this A1Y?
A1y. How I got? See, this is the base test, A1x.
Okay,
I just A1x. So what you have to do, you have to keep two values constant and change the third value.
right,
So if I change A1, keep this constant, I get y.
right.
Now x and y I have covered both, so there is nothing else to cover. So now I
Nothing
go
else.
to, I keep a and x constant, I get 2.
Right.
Now 1 and 2 both have been covered. Now what I will do, I will keep a
1x.
1x constant, so here b will come.
Right.
Now c is remaining, so
Right.
c1x.
Right.
So these are the 5 test cases for BCC. And formula for this is 1 plus I is equal to 1 to n bi minus 1. So 1 plus 3 minus 1 plus 2 minus 1 plus 2 minus 1. 1 plus 2 plus 1 plus 1 is equal to 5 for BCC. Okay, in one of the PYPs they have asked this question, the number of BCC. So that we can do. And now we come to multi-base. Multi-base means now we had selected only one base here, A1x. Now in case okay, we select two bases, for example A1x and B1i, and then do the same exercise. So then we will find okay, some of the test cases they will be common in both. And in that for the formula is m plus summation I is equal to 1 to n m into bi minus mi. What are the choices?
But this will not remove the common ones, no? This formula.
This is I think removing.
So here you have 1, 2, 3, 4, 5, 6, 7, 8 minus
It is
2.
10 minus 2. Here it is 5. Here it is 5. This
Okay.
2
Oh,
and
okay, yeah, 5. 10 minus 2 is 8.
yeah.
Okay. And here you're doing 2 into 2, 3 minus 2. What is 3 minus 2?
For A, this A has got 3 characteristics bi.
Right.
The 1 2 had x 2 and x and y 2. And
Yes.
here you see A and B I'm changing. A, B I'm changing. So how many test cases I have taken care from this? I have taken 2. 3 minus 2.
So in
For ABC,
okay, you have taken 2, right?
yeah. For
Okay.
x and y, you see I'm taking both 2. And why I have made okay, this 0? Because whether I keep 1 or not keep 1, I will have to cover both 1 and 2. So this I have to keep
So
0.
I'm not clear. How does it apply with the formula here? See,
Okay.
I'm getting this 2 into the
So
first block
formula
is
is
3.
2 plus
Yeah.
summation 2 into plus 2 into plus 2 into 3
Right,
minus 2 minus 2 minus. Okay.
right.
Now for the ABC, I selected A1x and B1y. These are my two test cases. So for
Right.
ABC, I have selected two values,
Right.
3 minus 2. For x and y, I have selected both values, 2.
Right. So
Now for this 1 which is there, it is a very, very peculiar case. Whether I select 1 or not, it does not make any difference because this 1 and 2 will be covered later on in my test case. So this means that I'm not selecting anything for this one. And when you solve this, then you get 2 plus 2.
this last one is still, I'm sorry, not clear.
Yeah,
So
yeah.
one,
This is like a slightly. I also struggled with this, but then I found like on the online like I carried out some cases. Like I saw some examples. So there I saw where you're taking only one value for this,
Right.
then they say that okay, it is 0.
Okay.
So I'll try to find like a much more also on this again.
Okay.
And I understand this is confusing slightly. Yeah. So now I will come to PYPs of this PK. Okay. So these are the notes. GS we have seen, we have solved it. I have covered the three guidelines here, which are there. If it is within range, values, and ordered set, we consider that epsilon point, disjointness, completeness. This we have seen example. This they have given like the characteristics. These are the characteristics. Like this is one characteristic, second characteristic, third characteristic. Number of
Okay.
partitions 1, 2, 3. 1, 2, 3.
3. Right.
For this partition is how many? 4. 1, 2, 3, 4.
Clear.
So
Clear. Right.
for AOCC will be 3 into 3 into 4. For ECC will be max of this. So max will be 3, 3, 4 is 4.
4. Right.
Okay.
Clear.
Yeah. And how many test cases are required to satisfy the base choice criteria? So here this question has come. So
Yes.
this is the formula which we used.
Yes.
So
This simple. This. Yeah.
yeah. So this is simple. Okay. And how many test cases are satisfied? So we have
This
seen
clear.
this.
Right.
Yeah. Now this is a question. Just pay attention here. This is from GA only. Now here you see here they have given the domain. This is the input domain. 18 to 100. Gender, values, male or female. So this is the domain they have given. That it can be either male or female. Age can be from 18 to 100 only. Annual income from 500,000 to this much here. And when we make this, now these are the things on the basis of which we have to make the partitions. And the 4 rules I have written
So
for example,
partitions are made based on the rules, right?
on the basis of the rules. So these are the rules and this is the domain.
Okay.
Okay. So see, so I made here age is less than 60, age is less than 60, greater than 60, and here age is not there. So for age, there are only 2 partitions, less than 60 or greater than equal to 60.
Right.
Gender, only male and female.
Right.
They are given. Okay. Income also, if you see, here there is no condition on income. It is only age and gender. Standard deduction is this. This. Only income part has come only here. Okay. So income
Yes.
are the 2 partitions either greater than this or less than equal to this. And this question is basically the decision table. And now you are making a decision. And you know the domain also. Domain is 18 to 100 only. So age is less than 60. Gender, here okay, you can write okay, these are the conditions. Age is less than 60, yes, no, or it does not matter. So first rule says if it is yes, gender is male, standard deduction is how much? Even. So here is even is this is your standard deduction. So effect. The second condition you come here 1,20,000. Here you come
You
1,50,000.
put 1 0 less the
For which
3, 4, 5. There's 2 crores, sir. The last fourth what? Yeah, income wale mein decision table income greater than 2 crores.
yes this
Even
one.
here it should be 2 crores. Upar bhi.
Yes थोड़ा सा difference.
Sorry, I'm a finance guy, so I can.
Okay, so this is a decision table, and now when you will give the values to them, you will keep the values in the domain again. Remember this again. So these conditions which are there, like for you, it is very
So I
easy.
can put this as greater than 60 also, and then can I not? See,
When
you put age less than 60, but my partitions are 2.
but okay, if you will make them 60, then it will not be complete.
Complete, right.
It will not cover 60. If, for example, if somebody's age is 60,
No, I'm saying greater than equal to 60, but then it will skip all these rules.
No,
No,
it will
so
don't take it.
okay, so here I can make greater than equal to 60 also.
So it is greater than equal to 60 only.
No, you've taken age less than 60 and you put
So
rules yes, yes, no. If I take age greater than equal to 60, then I'll put no, no, yes, and dash.
no, this is the no condition here. These are the conditions. The third condition is greater than 60. So this is no.
No, no, I agree that because
Yeah.
you put here you put
Okay.
age
So
less.
you want to say I can keep it like this only also,
Yes,
and then
yes,
it will become no, no, yes.
yes.
Okay, yeah, that also can be done.
That we can do. Okay, okay.
And when you make this decision table which is there, then easily we can check the conditions which is there. Okay.
Yes,
And now we can see that age is 45, gender is female, but
right,
what is
right.
the lacuna in this again? This is incomplete. Okay. So here we have
Yes,
checked it here. Which of the following is a valid test case input for boundary value analysis of the above system? Annual income is 25, this is age is 55, gender is male. Now see, for this 25, your age and gender doesn't matter. You see the rule. In this rule,
right,
when your age is more than 20 crore, then your age and gender does not matter. It is clearly given,
right.
irrespective of the age and gender. That's why it is not provided. These are all the requirements. This is on a joint and disjoint and complete, which we have covered. If you see here, the first example, n is less than 0, n is greater than 0. It is disjoint but not complete because it is not covering is equal to 0. N is less than equal to 0, n is greater than equal to 0. It is complete but not disjoint because both are covering 0. N
Right.
is less than 0, n is greater than 0 and 0. This fulfills our requirement. Okay.
Yes.
Yeah. Now we come to this. Consider input space partitioning for a program that computes the bonus for this. Now see here, these are the characteristics. We can say 1, 2, 3, and 4. And they have given the partition also. Now, what is the minimum number of tests required to satisfy all combination coverage? So here see 2, here see 1, 2, 3, here we see 3, here see 1, 2, 3, 4. So for ACOC is multiplication 2, 3, 6, 3, 18, 4, 72. Okay.
Right.
Now, similarly here they have given, consider the base choice given here. Salary is this, experience, gender, grade is equal to D. What are the minimum number of tests, including the base choice, required to satisfy BCC? Okay, so it is from here only. So BCC we know. So we apply the formula, we get the answer.
So what is the base choice they give it? Okay. They are
They have
given,
given
okay.
single base choice.
Single. Okay.
Single base choice. Okay.
Right,
So
right.
we
Clear,
applied.
clear, clear.
Applied. This is a normal business requirement, user requirement question. Now here, this was I mentioned earlier that how you make the partitions. Now consider a banking web application that determines the annual interest rate. This is this. The tenure can be from 1 to 20 years. So this
Right.
is 1 to 20 we have made. Tenure is between 1
Right.
and 5, rate is 11. 1 to 5 is good. So see, already I got the partition. Less than
Yes.
equal to 1, I have got one partition. 1 to 5, I get second partition. 6 to 10, I get the another partition. 11 and 15, I get
Right.
another partition. And
Six.
then up to 20, I get another partition. And I have also to cover more than 20.
Yes, yes.
So
Clear.
I have got six partitions.
Right.
Okay. Now, suppose we need to test a program that takes an integer as input. The input domain can be partitioned into two equivalent classes, and input x is valid if x is between 100 and 10, and the rest are invalid. Identify the correct set of BVA for the valid partition.
Right. So this is a
So,
range. So we'll take,
yeah,
you said plus epsilon
epsilon.
at minus epsilon.
Yes, yes. So this is the correct one, and from here you select the values, whichever. So
Right.
here you see there are both options are correct. Now this question is again on the number of characteristics, partitions, BCC. Easily we can find out using the formula. Minimum number of test cases. Okay. Then the requirements. This we know. This we can do. Functional requirement. Now again this is on this. What is the
Can you go
minimum?
one above? Which is,
Yeah.
this is what?
This is again they have asked here number of tests required for ECC. So
Okay.
ECC is always
We will
max.
be
One,
max.
2, 3, 4.
4. Right. Clear. Very simple.
Yeah. And this is the question which we are struggling to find the answer. This PWC, what is the minimum number of tests required for the PWC? I tried, I got some answers, but I'm struggling with this because there is no
What was the
formula for this
formula was
PWC.
square of? Okay.
No. It was at least max of BI square. So ABCD is 4, so it will be at least 16.
Yes.
So we can say what the minimum number is 16. So that
Yes. But here, what is the
BCC
answer actually? In this
answer they have
what
given
was
PYP they have given answer 15.
okay. So maybe the
So
other
that's why I'm
choices
confused
were
because they are saying,
okay.
but why then they should write at least.
At
So
least,
I
right.
will post on Discord second. I'll share the link
Okay.
also. So BCC this is easy. BCC we can
This is
solve.
clear.
This again the partition is there. Partition is easy now. We can do
Right.
that. Okay. So here we have to identify. We can do that.
Right.
BCC again easy. So when it comes to the partition based testing with multiple inputs, which are the following technique is better than the others? We know decision tables
Decision.
that we have seen.
Right.
Okay, so these are the questions. This is the last one. Okay. So I think we have covered most of the topics okay, from week 5 to week 8. In case anything is
Yeah.
there, please post on WhatsApp. Okay, we'll discuss. There are certain ambiguities we'll try to resolve. And thanks a lot for your time and your patience for this.
Thank you so much for your time.
Thank you, sir. Thank you so
Really,
much.
very
And
helpful.
just please do make this recording available.
Yes, I'll do that, and I'll share this.
And you're
I'll
working, so that
share,
I'll work out again.
Yes.
Then you won't forget.
yeah. I'll share this document also, and have a very nice day. All the best. Bye bye.
Thank you, sir.
Thank you so much.
Bye.